Right now, you are trapped. Not in a room. Not in a situation. In something so invisible, so total, so deeply embedded in every moment of your life that you have never once looked directly at it. You wake up inside it. You eat inside it. You fall asleep inside it. Every appointment, every deadline, every birthday, every countdown, all of it exists inside this one invisible structure that nobody ever chose and nobody ever questioned. It's called time. And here is the thing nobody tells you. We made it up. Not time itself, time is real. The universe is real. Stars burn and die and the earth turns and your body ages and none of that is fiction. But the version of time you are living inside right now, the hours, the minutes, the zones, the calendars, the Monday mornings and the Sunday nights, that version is a human invention. Built over thousands of years. By priests and astronomers and clockmakers and railway companies and colonial governments. Each of them adding a layer, each of them making a decision, each of those decisions eventually becoming something you check on your phone without a second thought. And the story of how that happened, how we got from a prehistoric human staring at the sunrise to a billion people synchronized to the billionth of a second, is one of the most extraordinary stories ever told. It involves shipwrecks. And empires. And a carpenter who humiliated the greatest scientists in the world. And a moment where one man, in one room, drew a line through the earth and said, "This is where time begins. You will never look at a clock the same way again." 40,000 years ago, on a hillside somewhere in what we now call Europe, a human being stood at the entrance to a cave and watched the sun disappear behind the mountains. She was not primitive. Not in any meaningful sense. Her brain was identical to yours. She could reason, plan, love, grieve, imagine. She could look at the sky and see patterns. She could look at the past and learn from it. She could look at the future and feel afraid of it. But she could not say, "I will meet you here in 3 days." Not because she lacked the intelligence. Because she lacked the system. There was no agreed upon unit called a day. There was no count. There was just, the light comes, the light goes. The warmth comes, the cold comes. The berries ripen, the berries die. Life moved to a rhythm that was felt, not measured. And here is the thing that almost nobody appreciates about that world: it worked. For tens of thousands of years, it worked. Human communities survived, traveled, hunted, raised children, built cultures, all without a single clock or calendar. They didn't need to know it was Tuesday. They needed to know that the rains were coming. That the mammoth herds moved north in spring. That the river would swell before it shrank. They weren't outside of time. They were inside time in the most intimate way imaginable. Completely immersed. Completely dependent. Not measuring it, living it. But nature is not always gentle about her rhythms. And nothing concentrates the human mind like starvation. Because here is the brutal reality of life without a calendar. You can be too early, and the harvest isn't ready. You can be too late, and the flood has already come and gone, taking the fertile soil with it. The difference between reading the sky correctly and reading it wrong was not inconvenience. It was survival. It was the difference between your children eating and your children dying. And so, slowly, painfully, over generations of observation and failure and hard-won memory, certain human beings began doing something extraordinary. They began keeping score. Archaeologists have found bones, ancient, carved, dating back 25,000 years, marked with sequences of notches. For a long time, researchers assumed these were tallies of animals killed, or some kind of primitive art. Then someone looked more carefully. The notches weren't random. They grouped into patterns of roughly 29. Then 29 again. Then 29. 29 and a half days. The lunar cycle. These weren't hunting tallies. They were calendars. Carved into bone by a human hand, in the dark, 25,000 years before the Egyptian pyramids. Someone, somewhere, had looked at the moon and thought, "I need to remember this. I need to count this. I need to know when it's coming back." That impulse, that very specific, very human impulse to not just experience time but to capture it, is where everything in this story begins. But capturing time and controlling time are two very different things. And the leap from one to the other happened in a place so specific, so dramatic, that it almost feels designed. It happened in the shadow of the longest river on Earth, in a civilization built on the edge of catastrophe. And they had roughly 4 weeks to get it right. Every single year. without fail. Picture Egypt. Not the tourist Egypt of postcards. The real Egypt. A thin green ribbon of life pressed between two walls of absolute desert. No river, no life. No life, no Egypt. The entire civilization, millions of people, cities, temples, armies, gods, existed only because the Nile flooded once a year and left behind soil rich enough to feed an empire. One flood. Once a year. Everything depended on it. Miss the planting window after the flood, even by a few weeks, and your harvest is weak. Plant too early, before the waters have receded, and your seeds rot in the mud. The timing was everything, and the Nile gave no warnings. It didn't slow down before it rose. It didn't send a messenger ahead. One day the water was normal, and then it was rising, and then it was everywhere, and then it was gone, and the clock was ticking. The Egyptian priests, who were also the engineers, the astronomers, the record-keepers of their civilization, spent generations trying to solve this problem. And then one morning, we don't know exactly when, exactly who, exactly where, a priest standing on a rooftop before dawn saw something that changed everything. In the eastern sky, just before sunrise, a single star appeared on the horizon for the first time in 70 days of total absence. Blazing, brilliant, unmistakable. The Egyptians called it Sopdet. We call it Sirius, the brightest star in the night sky. And its return, that first ghostly reappearance on the horizon after weeks of darkness, reliably preceded the annual flood by a matter of days. The sky had sent a messenger after all. The priests began counting. Days from the rising of Sirius to the rising of Sirius. Year after year, they counted. And the number they arrived at, 365, was the length of the solar year, cracked open by naked human observation, with no instruments beyond patience and memory and bone-deep need. They divided those days into 12 months of 30 days each. 5 leftover days became a strange, sacred pocket at the end of the year, days that fell outside the regular calendar entirely, considered so unusual that in mythology they were the birthdays of the gods. The calendar had edges. And even the days outside the edges had meaning. But here is where it gets complicated. And this complication will haunt humanity for the next 3,000 years. The Egyptians had the solar year. The Babylonians, in Mesopotamia, built their calendar around the moon instead. 12 lunar months, neat, visible, trackable by anyone who could see the sky. But 12 lunar months is only 354 days. Not 365. 11 days short. Which means the Babylonian calendar didn't just drift, it somersaulted through the seasons. Left uncorrected, their New Year's Day would migrate backward through the entire year, hitting every season in turn, completing a full circuit in about 32 years. Their solution was breathtaking in its audacity. They simply invented extra months when they needed them. A king or high priest would issue a proclamation, there will be a 13th month this year. Adjust accordingly. Everyone adjusts accordingly. This means there were specific years in ancient Babylon where the authorities literally decided what day it was. Not observed it. Decided it. By declaration. And if you think that sounds like a strange, ancient, superstitious approach to timekeeping, consider that we still do this. Right now. We still do this. Every 4 years, we add a day to the calendar, February 29th, because our year is actually 365 and a quarter days long, and if we don't correct for the drift, the seasons slide. In the year 46 BC, Julius Caesar, trying to reform the Roman calendar, inserted so many correction days that the year lasted 445 days. It was called the Year of Confusion. The most appropriately named year in history. We inherited Caesar's calendar. We are living inside his corrections right now. But the calendar was only the beginning. Because once you can agree on what day it is, you discover you need something even more precise. Something that can tell you not just what day, but what hour, what minute. And the story of how humans built that kind of precision is a story of obsession, of competition, of enormous amounts of money, and of at least one man who nearly lost everything trying to prove that he was right. Here is a sentence from ancient Mesopotamia, roughly 4,000 years old, discovered on a clay tablet and translated by modern archaeologists. I will deliver the silver on the first day of the 3rd month. 4,000 years old. And completely modern. You could send that sentence in a text message today, and nobody would blink. That sentence is a contract. A promise reaching into the future, anchored to a specific point in a shared calendar. And contracts, the ability to make credible promises about the future, are not just a feature of civilization. They are the mechanism of civilization. Without them, there is no trade. Without trade, there is no specialization. Without specialization, there are no cities, no armies, no literacy, no mathematics. Without that clay tablet and what it represents, there is none of this. The calendar didn't just help farmers plant seeds. It made the future real. It turned tomorrow from a vague hope into a negotiable asset. And once tomorrow was negotiable, the people who controlled the calendar had something extremely valuable. Something governments have always wanted and always protected. Power. In ancient Rome, the calendar was managed by the pontiffs, a priestly college whose members were appointed by the Senate. They decided when to insert correction months. They decided when certain days were lucky or unlucky, which determined when courts could meet, when contracts could be signed, when elections could legally happen. A hostile pontiff could manipulate the calendar to delay an enemy's election, extend a friend's term in office, or invalidate a contract signed on a day he retroactively declared unlucky. The Roman calendar became so corrupted by political manipulation that by the time Julius Caesar came to power, it had drifted nearly 3 months out of sync with the seasons. 3 months. Rome was celebrating the harvest festival in summer. Caesar's reform, his 445-day corrective year, was not just administrative housekeeping. It was a seizure of temporal power. He was saying, in the most explicit way possible, I decide what time it is. For the empire. Forever. The calendar he created, with modifications added by his successor Augustus, whose name now lives in the month of August, is the one you are using right now. The Gregorian calendar, technically, but built on Caesar's foundation, modified in 1582 because even Caesar's math was slightly off. We have been correcting and recorrecting for 2,000 years, but all of this, the calendars, the months, the years, operated on a scale of days. The world was about to discover it needed something far more precise. Something that could measure not just how many days had passed, but how many hours. How many minutes. And the pressure to achieve that precision would come not from priests or kings or politicians. It would come from the sea. And the sea was not patient. It begins with a man lying on his back in a cathedral, not praying. Watching. Galileo Galilei, sometime in the 1580s, a medical student in Pisa who should have been paying attention to his lectures, found himself staring at a chandelier swinging gently from the ceiling of the cathedral. Someone had bumped it, and it was tracing lazy arcs through the air, back and forth, the arc growing smaller and smaller as it slowed. He had no watch. But he had a pulse. He pressed 2 fingers to his wrist and began counting heartbeats against the swing of the chandelier. And he noticed something that made him sit up straighter. As the arc grew smaller, as the chandelier slowed, the time per swing didn't change. Wide arc or narrow arc, the pendulum took the same number of heartbeats to complete a cycle. He had no idea yet what he had found. He couldn't have known that this idle observation in a cathedral would eventually solve one of the greatest navigational crises in human history. He couldn't have known that 70 years later, a Dutch mathematician named Christian Huygens would build the first pendulum clock using this principle, cutting timekeeping error from 15 minutes per day down to 15 seconds per day. Then, with refinements, to seconds per week. For the first time, time could be trusted. And yet, there was still a place where even the finest clock was useless. A place where all the precision in the world couldn't save you. A place where, if you got the time wrong, you didn't just miss an appointment. You sank. On the night of October 22, 1707, a British naval fleet of 21 ships was sailing home through darkness and fog. Admiral Sir Cloudesley Shovel believed he was safely west of France. He had consulted his navigators. He had done the calculations. His fleet was fine. His men were sleeping. He was wrong by 160 miles. Without warning, the flagship HMS Association struck the rocks of the Scilly Isles. She sank in under 4 minutes. 3 more ships followed her down. Nearly 2,000 men drowned in one of the worst naval disasters in British history. And the cause was not a storm, not incompetence, not enemy fire. The cause was a miscalculation of time. To understand why, you need to know something beautiful and terrible about the geometry of the Earth. The Earth rotates 360 degrees in 24 hours, 15 degrees per hour. Which means that if you know exactly what time it is at one fixed location, and you can observe local noon by watching when the sun reaches its highest point, the difference between those 2 times tells you, with mathematical precision, exactly how far east or west you are on the surface of the Earth. 1 hour of difference equals 15 degrees of longitude. Perfect. Elegant. Simple. Useless, because there was no way to carry an accurate clock on a ship. The ocean destroyed clocks. The constant motion disrupted pendulums, the very mechanism that had made them precise on land. Salt air corroded gears. The temperature difference between the tropics and northern seas caused metals to expand and contract by tiny but catastrophic amounts. The best clock in England, placed aboard a ship, would be off by hours by the time the ship reached the Caribbean. Hours that translated into hundreds of miles. Hundreds of miles that translated into rocks you couldn't see in the darkness. The British government, watching its fleet sink and its trade routes collapse, made an extraordinary decision. In 1714, Parliament passed the Longitude Act. The prize, £20,000 for a solution accurate enough to determine longitude within half a degree. £20,000, when an average sailor earned £20 per year. The greatest scientific minds of the age descended on the problem. Isaac Newton himself submitted testimony. Edmund Halley, of Halley's Comet, worked on it. Dozens of astronomers competed. The Astronomer Royal, Neville Maskelyne, developed an elaborate system using the moon and published star tables that worked but required 4 hours of calculation per navigational fix. On a heaving deck, in bad weather, at night, under enemy fire. And then there was John Harrison. Harrison was a carpenter. From Lincolnshire. A man with no university education, no aristocratic connections, no membership in the Royal Society. He had never been on an ocean voyage. He barely knew how to swim. He had nothing except a talent for clockwork so extraordinary that it bordered on the supernatural, and a stubbornness so absolute that it survived every obstacle the establishment could construct. He began work on the longitude problem in 1730. He would not finish until 1759. 29 years. He built 4 clocks, the H1, the H2, the H3, each one a masterpiece, each one not quite good enough. He poured years into the H3, and then he looked at what he had built and realized it was the wrong approach entirely. And he started over. The H4 looks nothing like what you'd expect. It doesn't look like a monument. It looks like a large pocket watch. 5 inches across. Silver case. Delicate, almost casual. You could hold it in one hand. On its first sea trial, sailing to Jamaica and back, a journey of months, through temperature swings from England's grey cold to Caribbean heat, the H4 arrived with a total error of 1 minute and 54 seconds. 1 minute and 54 seconds. Over a journey of months. On a ship crossing an ocean. The longitude problem was solved. Not by Newton. Not by the Astronomer Royal. By a carpenter from Lincolnshire who had spent his entire life being underestimated. And now, for the first time in history, you could carry accurate time with you anywhere on Earth. Aboard a ship, across a desert, over a mountain. Portable, precise, unstoppable time. Which raised a question that nobody had fully confronted before. When you carry time with you, when your clock says it's noon and the sun above you says it's 3 in the afternoon, which one is right? That question was about to become a crisis that shook the entire industrialized world. Here is something that sounds insane until you understand it, and then sounds completely sensible, and then sounds insane again. Before 1880, every city in Britain kept its own time. Bristol was 10 minutes behind London. Liverpool was 12 minutes behind. Edinburgh was 13 minutes behind. Not approximately. Exactly. These differences were natural, logical, and real, because time in each city was determined by the sun above that city, and the sun reaches its highest point at slightly different moments across a country 300 miles wide. For 10,000 years, this was fine. You lived in your city. Your city had its time. If you traveled, the change was so gradual you never noticed. Then came the train. On September 15, 1830, the Liverpool and Manchester Railway opened, the world's first intercity steam railway, and in doing so, quietly broke something fundamental about how human beings related to distance. The 35 miles between Liverpool and Manchester had always taken a full day by road. The train did it in under 2 hours. Suddenly, you could be in 2 different cities in one afternoon. And when you arrived in Manchester, your watch, set to Liverpool time, said something slightly different from every clock in Manchester. Not much. Not enough to notice in ordinary life. But for a railway company trying to print a timetable, trying to tell passengers when trains would depart and arrive, trying to prevent two trains from being scheduled onto the same track at the same time, small differences compounded into genuine disasters. And there were disasters. The Great Western Railway, fed up with the confusion, simply declared that all its trains would run on London time, regardless of what local clock said. Other railways followed. Travelers in Bristol began carrying two watches, one set to local Bristol time for life in the city, one set to London railway time for catching trains. Two different versions of Now, carried simultaneously in one pocket. Imagine that. Two different versions of Now. Not metaphorically. Literally. Walking around with two watches because reality had split into two competing timelines. The British government watched this chaos long enough to realize that someone needed to make a decision. In 1880, Greenwich Mean Time became the official time of all of Britain. One country. One clock. The local solar time of every city, the time that was real, that matched the sun, was abolished by parliamentary decree and replaced with the time kept by a telescope in a London suburb. And then the world had to do it too. Because if Britain could have one time, the industrializing world needed one system. International trade, international shipping, international telegraphs bouncing messages across oceans at the speed of light, all of it demanded that New York and London and Bombay and Tokyo could agree, at any moment, on what time it was relative to everywhere else. In October of 1884, delegates from 25 nations gathered in Washington, D.C., for the International Meridian Conference. Their task, to draw lines around the entire planet. To take the curved, indifferent surface of the Earth and cut it into 24 slices, each one representing 1 hour, and to declare one of those slices the beginning. They chose Greenwich. The 0 point. The prime meridian. The place from which all time on Earth would be measured. Britain proposed it for obvious reasons. France opposed it for equally obvious reasons. France had its own meridian through Paris, and had used it for centuries. The French delegation voted against the Greenwich Meridian and then, in one of history's most perfectly passive-aggressive diplomatic acts, continued using Paris time for the next 27 years before finally, quietly, adopting Greenwich in 1911. They did not call it Greenwich Mean Time. They called it Paris Mean Time, retarded by 9 minutes 21 seconds. They changed the name before they changed the clocks. National pride first. Accuracy second. But here is what the history books almost never tell you. Here is the thing that should fundamentally disturb your sense of how reality is organized. Because we have been building to this moment for the entire documentary, and it's time. The prime meridian, the line of zero longitude, the point from which all time on Earth is measured, passes through the Royal Observatory in Greenwich, London. You can visit it. You can stand on it. There is a metal strip embedded in the courtyard, and tourists line up to put 1 foot on each side of it, straddling the moment where time officially begins. Here is what that line is. It is a brass strip in the ground. Put there by humans. Agreed upon by delegates at a conference. Not found. Not discovered. Not revealed by nature or mathematics or the structure of the cosmos. Chosen. From a short list of options. By a vote. The Earth did not vote on its own prime meridian. The Earth doesn't have a prime meridian. The Earth is a spinning ball with no preferred longitude, no natural zero, no point that is more fundamental than any other. We put the line there. We could have put it anywhere. We almost put it somewhere else. There were serious proposals for a neutral meridian through the Azores, or through the Bering Strait, or through Jerusalem. We chose Greenwich because Britain had the largest navy, the most ships, the most detailed charts, and therefore the most leverage. The prime meridian of Earth is a geopolitical decision wearing the costume of a geographical fact. And now it gets stranger. Because not everyone accepted the agreement. Not cleanly. Not simply. Nepal runs on a time offset of 5 hours and 45 minutes from Greenwich. Not 5 hours. Not 6 hours. 5 3/4. Why? Because 5 hours puts solar noon in the afternoon, and 6 hours puts it in the morning, and 5:45 is the compromise that best approximates actual noon. Nepal looked at the global time system and said, we will join it, but we will join it on our terms. India runs on 5.5 hours, the only major nation with a half-hour offset. Afghanistan runs on 4.5. Iran on 3.5. These aren't errors or oversights. They are deliberate choices by sovereign nations deciding how to balance the demands of global synchronization against the physical reality of their own sunlight. And then there is China. China spans the geographical width of almost 5 natural time zones, from the far western deserts of Xinjiang to the eastern coast near Shanghai, a distance of roughly 5,000 kilometers. In a rational system, someone in Urumqi in the west and someone in Shanghai in the east would be looking at clocks that read 4 or 5 hours apart. Instead, China has one time zone, Beijing time, for the entire country, from every coast to every border. Which means that in Xinjiang, in the far west, the sun rises at what the clock calls 10 in the morning, and sets at what the clock calls midnight. Children go to school in darkness. Farmers eat lunch when the clock says nearly 6 in the evening. The clock and the sun are locked in a permanent 4-hour argument, and the clock wins every time, because the clock represents Beijing, and Beijing is the center of political authority. This is not an obscure historical footnote. Millions of people live inside this discrepancy right now. Tonight, eating dinner by what the government calls 7 p.m. and their bodies call 3 in the afternoon. Spain is no different. Spain sits at the same longitude as Britain. Geographically, Spain belongs in the same time zone as London. But Spain runs 1 hour ahead, which means that in August, the sun sets in Madrid at nearly 10 p.m. Spaniards famously eat dinner at 10 or 11 at night, a cultural habit so embedded that it's treated as a national characteristic, a quirk of Spanish personality. In reality, it's a quirk of Spanish politics. In 1940, Francisco Franco aligned Spain's clocks with Nazi Germany to express political solidarity. Hitler is long gone. The time zone remained. Spain has been eating dinner late ever since. The clock on the wall of every Spanish kitchen is a political artifact from 1940, still ticking. But let all of this settle for a moment. Let it really settle. Because we have traveled from a woman watching a sunset outside a cave 40,000 years ago, through Egyptian priests and Babylonian kings and medieval monks and a carpenter in Lincolnshire and a conference room in Washington. And everything we have found along the way points toward the same unsettling truth. Here is the thing that the history of time reveals, stated as plainly as possible. The structure of time as you experience it, the hours, the minutes, the weeks, the zones, the calendars, is entirely constructed. It was built piece by piece, decision by decision, by human beings who needed to solve specific problems, and whose solutions were adopted, modified, inherited, and eventually forgotten to be human at all. It became invisible. It became natural. It became the background of everything, which is the most powerful form of authority anything can achieve, the authority of being taken for granted. And yet the moment you look at it directly, the strangeness refuses to go away. The 7-day week is a Babylonian invention, probably derived from the lunar cycle, adopted by the Romans, spread across the world by empire and religion. There is nothing in nature that produces exactly 7 days. No planetary cycle, no biological rhythm, no astronomical event produces a 7-day unit. The week is entirely human. And yet you have never, not once, lived outside of it. The names written into your weekly calendar are the names of planets and Norse gods. Thursday belongs to Thor. Friday to Frigg. Saturday to Saturn. These are the mythologies of dead religions, compressed into 2 syllables, used billions of times per week by people who believe they are simply talking about a section of a planner. The year begins on January 1st, a date with no astronomical significance whatsoever. It is not a solstice. It is not an equinox. It is the date of a Roman religious festival from the 2nd century BC, preserved through institutional inertia for 2,000 years. Different cultures have placed the new year at the spring equinox, at the winter solstice, at the harvest, at the flooding of a river. We place it in the gray middle of winter because Rome did. And even the hours of the day, the 24 hours, 60 minutes, 60 seconds, trace back to Babylonian mathematics. The Babylonians used a base 60 counting system, not base 10 like us. They divided the circle into 360 degrees. They divided the day into 24 hours. We never found a better system. We never even looked for one. We simply accepted what Babylon gave us and built atomic clocks on top of it. The most precise timekeeping technology in human history, the cesium atomic clock, accurate to 1 second in 300 million years, uses as its framework a structure invented by people who also believed in omens and read the future in animal livers. This is not a criticism. This is a miracle of continuity. The most ancient and the most modern parts of human civilization, connected by an unbroken thread of need. And now, at the very end of this story, there is one final question waiting. The deepest one. The one that physics has been circling for over a century without fully grasping. Is any of it real? Albert Einstein was 26 years old when he published the special theory of relativity in 1905. And one of its consequences, stated calmly, in the middle of the paper, as though it were unremarkable, was that time is not constant. Not that clocks are imperfect. Not that our measurements are approximate. That time itself, the physical phenomenon, the fabric of reality, moves at different rates depending on how fast you are moving and how close you are to a massive object. Time passes slower near a black hole than far from one. Time passes slower at the surface of the Earth than in orbit above it. The difference is tiny, but it is real, and it is measurable. GPS satellites have to correct for it constantly. Their onboard clocks run slightly faster than clocks on the ground, because they're farther from the center of the Earth's gravity. If engineers didn't account for this, GPS navigation would drift by several miles per day. The clocks are correcting for the curvature of time. Right now. In orbit. Because Einstein was right. Which means that if you and I were to separate, you remaining on Earth while I traveled near the speed of light for what felt to me like a year, when I returned, decades or centuries might have passed for you. Not because of some illusion or perceptual trick. Because time genuinely ran at different rates for us. Your past and my past would have been real, but they would not have been synchronized. We would have lived in different times, the way two people can live in different countries, occupying the same planet but not the same version of now. And at the quantum level, at the scale of electrons and photons and the particles that make up everything, things become genuinely disturbing. The equations that describe quantum mechanics work equally well whether time moves forward or backward. The mathematics doesn't care about the direction. Time's arrow, the sense that the past is fixed and the future is open, that you can remember yesterday but not tomorrow, that arrow appears to be a feature of our scale, our size, our perspective. At the deepest level of physics, the universe doesn't enforce it. The block universe theory, held seriously by physicists, not just philosophers, suggests that all of time exists simultaneously. That the past is not gone. That the future is not unwritten. That every moment, past and present and future, exists with equal reality, the way all the pages of a book exist even when you're only reading one. That the sensation of time passing, the most intimate, undeniable sensation in human experience, is an artifact of consciousness, not a feature of physics. If that's true, then what we feel as the present moment is something the universe doesn't have a word for. And yet, here you are, feeling it. We began with a question. A simple, strange, slightly threatening question. What if time isn't real? And now, on the other side of this story, the answer is both more reassuring and more disorienting than it seemed at the start. Time is real the way experience is real. The way love is real. Real enough to organize your entire life around, real enough to fear running out of, real enough that no argument about physics or philosophy has ever made anyone stop aging. Whatever time fundamentally is, and the most brilliant minds alive genuinely disagree, it is not nothing. But the version of time you inhabit? The hours and the weeks and the zones and the calendars? That was built. Slowly, desperately, brilliantly, piece by piece, by human beings trying to solve problems that were, at the time, life and death. The Egyptian priest who needed to predict a flood. The Babylonian merchant who needed to honor a contract. The medieval monk who needed to pray at the right hour. The British sailor trying not to drown. The railway engineer trying not to crash two trains. Each of them reached into chaos and tried to impose order. Each of them made a decision. And the decisions accumulated. And the accumulation became a system. And the system became invisible. And invisible things become natural. And natural things become unquestionable. That is how time as you know it was born. Not revealed. Not discovered. Built, the way a city is built. One structure at a time, each one built on top of what came before, until you forget that any of it was ever built at all. You are living inside a construction so vast and so old that its scaffolding has become the walls. The scaffolding has become the foundation. The scaffolding has become the ground beneath your feet. Every Monday morning, you are waking up inside Babylon. Every Thursday, you are invoking a Norse god. Every leap year, you are correcting for Julius Caesar's math. Every time you cross a time zone, you are crossing a line drawn by diplomats in 1884, a line that exists on maps and in legal documents and inside every phone and satellite in orbit, but nowhere else in the physical universe. And somewhere right now, a child is tugging on a parent's sleeve. What time is it? The parent glances at a phone. That phone syncs to an atomic clock. The atomic clock measures the vibration of cesium atoms 9,192,631,770 times per second. That frequency was calibrated to match the second as defined by Greenwich Mean Time. Greenwich Mean Time was decided by a conference. The conference chose Greenwich because Britain had the best navy. Britain had the best navy because it needed to navigate. It needed to navigate because ships kept sinking. Ships kept sinking because they didn't know where they were. They didn't know where they were because they couldn't keep time at sea. They couldn't keep time at sea until a carpenter from Lincolnshire spent 29 years building a watch. And the parent looks up from the phone. It's 3:30. The child nods, already moving on. Already living inside the answer, the way we all do, never stopping to wonder who built the clock, or why, or what it would mean if they hadn't. But now you know. And you will never look at a clock quite the same way again.